Hi, myself Mohammad Faizan, and in this video, we will explore how you can build a scalable notification system, or you can say industry grade mail system. If you have thousands of mail per day, then you are able to handle with that system. We will follow industry grade product project structure, which we will use monorepo with PNPM workspaces. We will not use NPM because NPM is not good for industry because now industry shifted to the PNPM burn like things, but bun is let's ignore the bun. But now we will stick with a PNPM. And believe me, this project structure is awesome. If you won't believe on me, I put it the repo link in description. You can go and check the repo. Okay. By the way, if you are a beginner, then maybe this video is not for you. But if you wanna know how industries work, and how you can build an industry grade thing, or you can say how you can write industry grade code, how you can write testable codes. So if you wanna know, you can proceed with this video. But maybe this is not suitable for you. But for learning, it's awesome. And if you are a mid developer like me, because I am also you can say the mid level developer, so I mean, I am still in learning phase. I am learning, and I am also sharing my learning with you guys. So with these kind of videos, so I think it's there is not too much to talk. Let's code. And by the before coding, I will explain everything with a diagram how it works. Because if you are a beginner, then it help you to learn. Okay, learn the thing how things are working. So now let's go with the now let's start it with the explanation, and then we will look through the code. Okay, let's see what I included in this video. Okay, by the way, this video is fully loaded of values. Okay, don't go on its time. Maybe it will go on 1 hour almost. But in the 1 hour, I will deliver as much as possible values. Okay, this whole video is full of the values. I I dropped my all plan to create a full stack projects of 13 to 20 hour videos, because I think this is the best way to deliver the values. Okay, because I have already covered the basics things. Okay, so now basic things is, and the I created a I think three or four full stack project. And after that, if some after that, if anyone completed that project, so then now he is not a beginner, and now he is able to build some production ready thing. Okay, so uh, if you are still in the watching tutorial, so maybe bro you are in the tutorial hell, so get out the tutorial hell and build something yourself. Okay, now what you will let's see. By the way, in this video my main focus is to telling you queues, how queues work. Okay, in this video we will use BullMQ. Okay, let me show you the BullMQ. So here is the BullMQ. Okay, I talked about the BullMQ on my channel multiple time, but never used. In this project I will use. But if you're thinking I will use BullMQ just a basic, no, I am not gonna use this BullMQ for a basic thing. I will build whole messaging system. Okay, if you are thinking the messaging system is a basic thing, we will send only mail. So bro, you are wrong. Let me show you my full project structure. Have you ever seen this kind of project setup for sending the mails? Okay, I think on YouTube, no one will gonna talk about this. Okay, believe me, this is the industry grade code. I have written the whole industry grade code in the monorepo with a microservices. Okay, so it's a full industry grade code, believe me. Because now here you can see I have a package. In the package I have defined the BullMQ thing. Believe me, it's really a awesome thing. Okay, here's the central module for the managing the BullMQ. Worry not, I will show you everything. I will show you everything. Okay, what we will talk. By the way, I'm not gonna code anything, because coding this kind of thing is totally waste of time. I have written a node, you can say I have written a readme file, so you can just go and read the readme file. But worry not, I will cover everything. So now I think it's enough. Now let me show you what the thing I will go and talk. Okay, so why the QQ system are used in real world, understanding the producer QQ and architecture, difference between the synchronous and asynchronous task. But by the way, this is the not a task for this video, because I am not gonna talk about this. But what we are doing, which is asynchronous task. Okay, so I have just added. And now here the BullMQ fundamental setting with Redis, producers, workers, handling concurrency and processing and jobs in parallel. The things we will handle. Reliability and retry mechanism. We will implement automatic retry on email failure or exponential back off. Yeah, we will also handle this. We will. By the way, we are not adding the anything for dead letter QQ, but if you want, you can create anything for storing the dead letter QQ. It's on you. You can chat GPT to ask what the possible thing that you can do to handle TLQ. But if you don't, if you're not aware of TLQ, let me show. Suppose if you have a system for doing something, suppose doing something, and you have set the retry for 10 times. If that thing failed 10 times, then you will pass that message or that or thing or that anything which you want to process, and you failed to process that in for 10 times, then you will pass that into some kind of storage, some kind of thing. Maybe you will send that on email, maybe you will log that thing on Sentry. Anything you can do to handle the DLQ. Okay, so the DLQ is that the thing. And rate limiting is scaling, preventing limits. Okay, to how traffic burst off if 10k user log in simultaneously. The scaling strategy with a job. By the way, this I will not gonna talk about the strategy, but you can also chat GPT it. And this is the industry grade implementation. You can integrate these things with any technology, says node mailer SandGrid, but I am using in this video which is recent, because recent is easy and not sponsored. And separating the responsibility procedure app, and yeah, it's a separate thing. I have built a separate thing. And real world use cases, you can use this into the newsletter thing, and you can build a newsletter thing with this. Okay, believe me, that's gonna so scalable. And OTP transaction, you can use the a priority thing to do this kind of thing, OTP and transactional emails. Okay, by the way, of transactional email, maybe it's some kind of thing, welcome message. When a user do something, then you trigger anything, that's a transactional. OTP is also called in the transactional messages, so it's also transactional, but OTP is priority too high. So you need I will also tell you how you can make a priority high, low, medium with multiple queues. Okay, BullMQ have another way to handle priority, but I like to do it in different way. Okay, guaranteed mail delivery and event driven notification system. By the way, event driven notification is best when we use Kafka, but we are not using Kafka. We are just using the BullMQ in this project, but I am planning another project in that I will use BullMQ and Kafka both. So by the end of the project, you will build a production ready email delivery system. Understand how the real systems and companies handle millions of emails, implementing queuing system, marketing your project, and industry grade and unique. Okay, so I think it's enough. Now let's talk about the architecture. Okay, how we will approach and how we will build the thing. So let's suppose here is your client. So it's a client. There is a client and client generated some email. So I have built a mediator server, which I have also talked about my buffer system video. I like to build a mediator server. So it's a mediator server which will receive all the messages from the front end. So media. By the way, don't go on my spelling. I don't know the spelling of mediator, so ignore that. Okay, if user request in email, let's suppose user request mail with high priority. The message, I mean, the request with high priority, maybe it's OTP. OTP has high priority because you need to deliver OTP, because all OTP has expiry. So you also need to deliver that into under 5 minutes. That's why you need to. It's a high priority queue, a high priority thing. Okay. So here a BullMQ producer here. You can say the BullMQ producer, but in the BullMQ term, maybe there is not any producer term. There is just QQ and worker. Let me see. Yeah, you can say in the BullMQ there is no producer. There is only jobs, worker, and queue. But you can imagine there is a producer. Producer means who produce the messages. So you can imagine that. And here it's a mediator server. Its job is to if they receive, then it will notify our server. Our server means our main mail server. It's our main server who is responsible for the handling mail jobs, trial system, and everything regarding the mail. So this will just what this will do. This will publish messages into this will publish messages into the Kafka. Okay, not Kafka, BullMQ. Sorry for that. Because currently I'm using Kafka too much. That's why that in that is my on my tongue. So this will produce the messages into the Kafka, not Kafka, BullMQ, and this will pass that messages into the mail server. Okay, under the hood, our BullMQ uses Redis. Okay, so everything will store on the Redis. Okay, so everything will be stored on the Redis, and BullMQ uses Redis for their state management. So this is this server is our producer. This will produce messages in the our BullMQ. So let's also write a producer here. So producer, and this is the consumer. Job of this mail service is to consume the messages which is produces by the our mediator server. So it's a consumer. Okay, so it's a consumer. Okay, so this is the whole core thing what we will build. But I know you don't know about the BullMQ and QQ system, how QQ system works. So now let's see how this will work. Okay, so let's suppose it's a queue. Okay, it's a queue of messages. Okay, this is the queue of messages. If someone if someone requested or any request generated for a mail, let's suppose anything happened on server, anything happened by the user that generate that trigger a mail. Okay, so what this will do, this will just publish. Okay, after this you can see this server means this is the BullMQ part, this one, and this is the overview of this. Under the hood what will MQ will do. So this mediator server produce messages in BullMQ. So it's a BullMQ view. So BullMQ internal view, BullMQ internal view. Okay, it's a BullMQ internal view. We will see what internally handled by the BullMQ. How internally handles BullMQ this thing. So this will publish all the request in the queue. So it's a queue. All the messages will be published here. Now all the messages in our stack, every message has their id 1 2 3 4 5. Okay, it's a serial id given by the BullMQ, and this server will consume these messages. Okay, so the consumes means this takes this message. This will take one message. It's a worker, and worker of BullMQ. So it will take this message and process this message, and if done, then it will pass in the completed queue. And again come here, again this will process this message, and again done. And also this process, let's suppose the chance of this three message id number 3, the id of this message is 3. Okay, now suppose this, and this fails. This fails. Let I don't know boolean under the hood how handles, but I see in the BullMQ there is also a fail key for storing this. So let's suppose it's a failed one time, but you have set uh, 5 retries. Retries. Maybe spelling is not right, but just adjust it. uh, it's let's suppose you have set the 5 retries, and with some exponential back off minimum that much time you after a minimum after that much time you will again try to retry it. So this will go last in the queue. Okay, here this will go last in the queue, and it will wait for its time. Okay, after that this message will process all the message process, and when its time come, this will again gonna in the worker, and this will again processes. And if this again fail, this will again go in the last of the queue. And if the again chance come for this will again come here. If this fail again, this will again come here. This is the whole thing which BullMQ internal do. Let's suppose now what it's failed 5 times. Okay, it's our max retry system. If this fail, so we will receive then into our on failed. Okay, BullMQ has a callback, not callback, it's a listener which is on failed. Okay, on failed, FAI LED, it's LED on field. So you will receive this message in the on field, and from the on field you will able to process this message. Okay, so whatever you want to do, you want to pass this to sentry to log or anything, you can trigger the mail. You can pass in the DLQ queue, whatever you want to do, you can do. So this is the whole overview of BullMQ, how BullMQ work. But it's simple. You can say the BullMQ is simple. By the way, this mechanism is called first in first out. If first goes in the queue, then it will first out. Okay, if this go first, then it will work process first. It's just a simple queue of a voting line. Okay, not more than. But BullMQ also support another thing, last in first out. But I am not gonna talk about that. You can go and read here. There is also the rate limiting and parallelism and concurrency. So we will talk about the rate limiting, and also I will talk about the parallelism and concurrency. So worry not. So by the way, this is the whole overview of BullMQ. And let's suppose you have set the concurrency. There is one more topic to cover. Let's suppose concurrency. This is the whole. This, by the way, this is the whole our mail server. And in the mail server, you will be able to define your BullMQ worker. So let's suppose this is the one BullMQ worker. Okay, so it's a worker. Basically, this worker job is to process those messages with connected respective queues. By every worker is connected with their respective queues, so this will process their respective queue messages. By the way, this is only one instance of worker, and this is slow. And yeah, believe me, this is slow. And if you want to increase your concurrent, by the way, I mean to say, if you want to increase the you want to make it more fast, then what you can do, you will increase the concurrency. Okay, and after increasing concurrency, let's suppose you have set 3 concurrency. Oh, what is here? Let's suppose you have set 3 concurrency. So after setting the 3 concurrency, uh, our worker has 3 instance. Okay, our workers perform 3 messages at a one time. Okay, so currently our server processes 3 mails at once. Okay, by the way, there is no duplicacy. If this worker get one message, then rest of the worker will not be get that message again. So one message processes only one time. uh, if that not fails, if that fails, then I don't know who will process that message next time. But I also okay, so now let's ignore it. And now here, worker. So now you have concurrency, and now it's this is the also the solution of the setting the priority. If suppose you have a high priority queue, okay, so you will set the concurrency for that queue. I mean, a worker for that queue, maybe 20, 30, 50, according to your system. Your system is able to handle thousands of worker instance, you can say concurrency. Yeah, you can set, but yeah, it's totally depend on hardware. And there is also the medium priority thing and low priority thing. So you can adjust that concurrency. Okay, so now here, what now we have to do? Now let's see how we will handle internally the priority thing. So now let me talk about the priority thing. So here the message produced by the server. Now let's suppose here we have 3 queues. Okay, let me delete this. So now let's suppose you have the priority, which is you have 3 priority: a high, medium, and low. And you will decide that priority here, what priority of QQ you wanna pass that message. So you have to decide that here maybe you will give that decision to the client. You have a ticket system. So that's totally depend. Okay, where you wanna manage that priority thing. So let's suppose you have 3 things. Okay, which produce the message high, medium, low. And high, let's suppose high have 50 concurrency, 50 concurrency. Okay, and medium has maybe 30 concurrency, 30 concurrency. And let's suppose this has maybe 10 concurrency. Okay, now you know the meaning of the concurrency and what I am trying to refer with the concurrency. And this will all pass their message into the single master queue. Okay, why I use this single master queues? Because currently, now let's suppose I have only one uh, API of my recent API, recent emails system. I don't know about the SES. In SES, there is any limit or not, but recent has the limit, and I am not sure about the what limit recent has. How much request they are accepting per second. So I don't know the exact number, but let's suppose it's a 300. Okay, it's a 300. You will only send the 300 messages in 1 second with the recent APIs. Let's suppose there is the limit for that. So if you pass, okay, if you handle that thing by the these three queue, so maybe you will fail somewhere. I mean to say, maybe at some point API limit will gonna throttle. Maybe it's exceed the limit, and then maybe recent block you if you do that is multiple time. So that's why it's good to have a master queue. Okay, I like to do that. By the way, this is totally optional. If you have any other idea, you can do. Also, you can manage the limit and concurrency here to match that 300 thing. So you can also handle that thing here with managing the concurrency and the limit per second. So let's suppose if except 300, you will give this 120 limit per second, and you will give 80 this, and you will give 100 this, or you can just adjust like this to just meet 300 per second TPS. I think transaction per second. It's also good to say TPS, but it's not TPS. Okay, by the way, I think it's TPS thing. Okay, let's ignore that. But I prefer to create a master queue that here I will only set my thing what I wanna do. Here I will set the concurrency high as much as possible, but it's not matter because there is a limit we have to set. Let's suppose I try I written I make 70 concurrency here, but the problem is this, the limit for this is the 300 messages per second. I am only here to process 300 messages per second, so that's why I'm on a limit. So for the limiting there in the BullMQ, I have a thing I have already shown you, rate limiting. We just have to set the limiter max how much we want to do the operation and duration. That's all to do here. So you want to limit to prevent the API throttling. It's whole about the our system, and this will not crash anyway. This will not, I mean to say, this is really an industry great thing for managing queues and managing this kind of request. You can do whatever you want. If you want, you can perform the millions of requests for the masses sending, maybe WhatsApp messages, maybe RCS. There is multiple thing that you can do, but I have taken the example of email because email is so common. That's why I have taken this, and it's the whole thing what I am going to do. And one thing I also want to tell you, which is the practical thing, when you implement then you will realize this criteria. By the way, setting this limit, it's not totally safe. Okay, let's suppose you have done everything correctly. You have set 300 messages per second with concurrency 70, or you can say the concurrency 1. Anything you have done here, but if you will test this whole thing in the MacBook with M1 chipset or M4 chipset, then it's probably high chances our this limit will not work. Okay, there is highly chance, I mean it's tested, I have tested this, uh, our rate limit will exceed. Okay, yeah, it's correct. Our rate limit will exceed, and it's tested by me, and I know this because I know when I I was working on the project, on a project which is a messaging thing, on which I we are u- we was using the API of third party API for sending the messages, and that API has limit. Okay, so this is the whole system that I was built for, that thing, that messaging system, and everything I have set it according to the rate limit. But in my system that was working perfectly. Okay, that will never hit any any API limit. Okay, but when I was tested with my colleague's laptop, which is the MacBook M1 chipset, a laptop. In their laptop, in his laptop, a rate limit exceeded. Okay, suppose I remember I was set that rate limit to the 50, but in MacBook that reaches 90, 100 messages per second. Okay, on that time I realize it's the setting here, the numbers, the setting of numbers here is it's not work, this will not work. Okay, you have to test everything according to your BPS where you will deploy your system. So remember this, this will not come, this will only come with experience. So it's a experience thing. So consider in this in your mind. Okay. Uh, and now I think it's enough to talk. And now let's see the code. And also I want to show you something. I have forgotten, but I think it's good thing to show how how I was calculated the rate limit. Okay, if rate limit exceeded or not. Let me show you. I was created a project for just for calculating the rate limit. Okay, I replaced that messaging API with my own build API, which is built on Hono, to calculate the rate limit. Basically, it's calculate how many requests comes per second, and that will write that request into a JSON file. And in the JSON file, if rate limit is exceeded, that will make true for that second. Yeah, you heard it right. I was built that server for calculating the rate limit. Let me show you. In future, if you want, you can also consider that. Yeah, you can say rate limit calculator. It's rate limit calculator. It's built on Hono. There is no readme, but it's just a simple server. So here, let me open this. Okay, so this is the BullMQ. You can say BullMQ rate limit JSON initial setup with initial setup without a limiter. This setup was with a limiter. By the way, this test is run on my machine. The Mac test file is I haven't I think I haven't a Mac test file that is on Telegram. I haven't added that here, but I have added my test results. So let me show you. This is the test result for the logs. You can say the logs for timestamp and what time I was sent the request. But the I think okay, 2197 messages is processes. Okay, I have downloaded that file into my system. Now let me show. It's a per second breakdown. You can see the second, this, and the time, and the request is 20. API limit exceeded, no. In my system there is nowhere true. Okay, so there is never I'll exceed the limit. Okay, but in MacBook that exceeds. Okay, so now it's a whole thing that I wanna show. And if you wanna know how this server works, so just a simple server. Okay, there is only one route which takes the request and processes some file fs module function for fs module operation. So it's all. By the way, I recommend you to convert this into the fs forward slash promises, because it's not recommended to do, but it's a small server, so no need to care. And also now it's time to see what inside my code and how I am handling, I mean to say how I implemented this whole logic in code. This is the repo. I added the link in the description, so you can go on the description and open it and just clone. Okay, just clone this repo. And after the cloning this, I prepared a whole readme file, so you can read from here all the servers where they are exist and all the commands. You just have to run first pnpm install. After that pnpm install, run pnpm build, because it's a mono repo, so you need to build your projects first to use. Okay, and after this just run pnpm dev. This will run all the dev servers. I mean, all means all dev servers. Okay, so now let me explain these on code. Okay, so I am running on my system. You can say I run the pnpm dev command, and because I have everything set up. By the way, this is the mono repo. So in the mono repo, you have to first build your packages and before use. Okay, because you need to install that packages in node module in your apps. By the way, let me show you. If you go in the package json of apps, come here, and you can see there is a dependency which is our own dependency. It's mailq utils. Okay, it's a dependency of our uk utils for a file. I mean utils package. So it's a basic mono repo thing, so I'm not gonna explain this much. So I have prepared a video on mono repo, so after this video you can refer that mono repo video because it's important. If you are building any big project, then you need to use mono repo. Okay, so mono repo is recommended. So you can use mono repo, and here in the package JSON you can see I am running multiple dev script in parallel to run all the dev servers. This is the and this is the build script. This will run all the build parallel and not parallel sequentially. PNPM decide self to which run first and which run after that because the packages depends on each other na? So that's why let's put them this on PNPM to build everything. By the way, if you failed any build issue, so you need to add your env file. In the env file you will find your env. I have added a env.example, so you can refer that. It's a env. It's for the mediator server. So our mediator server is this. Okay, so this is your mediator server. So our front end will connect from this server, and this server will connect from our server. Okay, by the way, this is the asynchronous connection, so there is no direct dependency. These are, you can say, these are the decoupled services. By the way, if you want, you can improve this more. If you use outbox method, you can write QQs in your database, and from database you can create a puller that will read the jobs from the data, and that will pass that job into the job BullMQ. The different way of handling. Okay, if you have millions of mails, okay, you need to send millions of mail, then maybe you can use Kafka. Okay, there is difference. Okay, by the way, this is, if you are thinking this is the whole, this project is so advanced, it is only for sending mail, this is the industry grade. Yeah, this is industry grade, but not fully, because in industry there are multiple things. Okay, multiple things require on the use cases, so you have to build. You have a senior. Okay, always you will be lead by a senior dev who will take care of this, and who will guide you. So the multiple thing happens in industry, but what we can just do here, we can just look the overview. Okay, I am not by the way, I am not saying anything. It's a fully industry grade. It's like industry grade, it's approaching industry grade, but it's not fully industry grade. There is so many improvement and so many things to do, but this is enough. By the way, if you are a medium size industry, man, say you are building a medium size app, so maybe 10,000 mails per day, that kind of thing, so this system will handle. Okay, but if you have too much numbers, so then maybe you need to do something. Okay, so keep it in mind. If you are starting anything in a startup and you need to build the MVP, so it's more than enough for a MVP, because in MVP you have just a prototype. So okay, you just to show, and you just to show how, what you build and what's your service, and you have just, you need to only onboard some users. But as your startup grows, you need developers. Okay, so only you will not able to build anything, you need a team. Okay, so so keep that in mind. So okay, I think it's enough. Now let's see on the project what's in the project. So now let me show the UI. Okay, so this is the UI. By the way, it's not a Next.js app, it's a V tab. So there is just a thing, email to and subject and HTML content and priority. Here are the three priority, low, medium, high. So I'm not gonna send this. Okay, because it's not needed. And one thing I want to show you, I am using the Redis, and Redis in my Docker container. Okay, so I ran this 15 minutes ago. So I am using the Redis from my local Docker container. If you want, you can use any Redis. So but I will recommend you do not use any serverless Redis like Upstairs. Okay, don't use Upstairs, because if you are using the BullMQ, so BullMQ generate multiple requests. Okay, multiple requests per second. So this will this will increase your bill on this kind of platform. So avoid this kind of platform. If you want any hosted, so I will recommend you to go with DigitalOcean, Wallkey, or go with Amazon. Amazon has also Redis, I think, Elastic Cache or Wallkey. I don't know the name of the service provided by the Amazon, but something like this. You can use them, or you can use Redis Cloud. Okay, Redis cloud is also good. So if you want, you can use, if you want any managed services, but I'm running on the I'm running on the Docker. I think it's enough to explain, because not required here too much. That's why I'm not putting myself into that too much. Okay, so now let's see first our UI. So our UI is available in the web. Okay, so this is our web application, and in the web it's a Vue React app, and everything is, by the way, this is the by the way, I am using sitecn to style my components. So it's app.tsx. In the app.tsx there is sitecn form. Okay, so let me show you the sitecn. This is just a sitecn form initialized by the React hook form, and here you can say on submit there is nothing. On submit, just I am calling the API with my location, mediator server location, and this is my the endpoint. Okay, and just a normal fetch thing. Okay, and there is a form who takes everything from the front end. So okay, it's done. Okay, so there is nothing to show, and now it's a mediator server, and mediator server has endpoint. So now let's see what mediator server is doing. So mediator server, here you can see index. So in the index there is not too much, there is just env config file. Make sure always add that our .env package at top of your index.ts, or you can set your entry file, and everything here of server related thing. And the application I am defining here, so you can see all the application here. If you want to put any authentication here, so you can add your authentication here. And yeah, it's a normal route for our Hono application, because it's our Hono application. I like Hono, I use Hono. Yeah, Hono is awesome. And also Express is awesome if you use Express with trpc, but also Hono has their own implementation of rpc, so it's totally different. Okay, so now it's done. Here you can say there is a mail, and also I am routing here, and that exists in the mail. Okay, so here is a mail, and in the mail what I am doing, I am just calling the mail router post, and yeah, it's a jot validator. If you want to learn more about this, just go on the Hono docs and search for jot middleware or validator, anything you will find. Okay, okay, so here just it's a parse body by the JSON by this jet validator, means JSON validator. And what I am doing here, I'm just destructuring the thing, because priority I don't want to send anywhere. I just want body without priority. So I just taking, I am just taking the, you can say I am destructuring thing, or you can say I am removing the priority thing. So it's anything you can, if you want, you can understand. But just I want above my body without priority. So I taken this here, and here I am just checking the priority. So if priority high, then pass into the high priority queue. If priority medium, so pass into the medium priority queue. If priority low, pass into the low priority queue. By the way, if you wanna use only one queue, so you can also use one queue, because in single queue now you are able to also define the priority thing. Because if you go on the bull, okay, let me show the BullMQ. BullMQ supports priority, retry, these kind of thing out of the box. But if you will use Kafka, they not support. If you want anything, you can, if you want retry system, then you need to build a retry topics for that. And okay, if you want DLT, you can say in the term of Kafka, DLT, you need to use DLT. And all, if you throw any error in your topic consumer, that will maybe create poison pill for Kafka. So you need to always take care about that thing. But we are on BullMQ, so BullMQ handle multiple thing automatically. So it's always have to best thing to do, use BullMQ with Kafka. Okay. Maybe if you will use Kafka, because I am planning a project with a Kafka for processing the video. Maybe I mean to say video, if you upload single video, that will process in multiple format that video parallelly. Okay, by the way, this kind of thing is done by the Kafka. Okay, by the way, if you don't want to use Kafka, this also the solution. Okay, you just have to create an entry in your database, and you can create of some fields, and you will create a puller for read that entry, that called outbox event, and you have to read, and you have multiple server to read that, and multiple thing you can do. Okay, so it's limitless. Okay, you can do many things, and it will depends on your system requirement, how much your system have traffic, and how you want to deal with them. Okay, so it's totally different. So I'm not talking too much about that. And why I am creating this kind of video, the thing is this, I want to share much value as possible. Okay, so now I think on the job, In the job you can say there is two things: first in first out and last in first out. So if you want you can define that, but my priority is to prioritize. Okay, so if you want you can use a priority based thing in the single queue. Okay, you have to just set the priority with number. So you can define the priority with number. There are multiple things to see. If you want you can read, but I don't like to do like this because I want to create multiple queues. Okay, this will create multiple request on your server. I mean you can say this multiple queues create load on your server. Yeah, it's true. And also it's create load on your Redis server. It's also true. Why na? Everything is depend on system requirement. Okay, if you want, if you have low infrastructure, if you have low budget, you can use single queue. Okay, with you can set the priority with on jobs. Okay, so I think I enough from here. Okay, so now here come here. And now by the way, if you are thinking how I am managing the priority with the queue, okay, it's totally simple. Let's first see. By the way, there is nothing more than the pushing jobs into the queue. Okay, so here I am just pushing the job into the, okay, and here just written some response. Okay, it's okay and it's done. Okay, no need to communicate with our other server. This is called asynchronous connection or decoupled services. Decoupled services mean not directly depend but depends. You can define like this. Okay, so now let me show. If you come here you can use, see the, it's uses QQ, and in the QQ there is a QQ. Okay, it's looks weird. Okay, weird. Okay, so why I use like this, I created a package for BullMQ that contain all the BullMQ configuration for creating the queue and storing the name. Because why we have two servers. Okay, we have two servers, one a mediator server and one is mail server. Those are totally independent. Okay, if you want if we want to share the queue, so we have to create that queue also for this and also for this. Okay, it's not good, we are repeating yourself. Okay, so that's why I created a package. Okay, here you can see I created a package for managing the BullMQ. So if you want you can also create, by the way, creating the packages in in monorepo structure, it's great thing to do. Okay, always recommended, but it's also depends on use cases. Okay, so now let me show you here the send router. So now let's see what's there. You can see it's a mediator server. By the way, these are the type alias which I have defined to just differentiate the thing. So now let me open this. Okay, so I opened this. You can see here it's coming from the mail queue BullMQ. It's totally weird. This kind of file not exist in our mediator server. So I will explain, worry not. Here I am calling the handler, and I am just calling this handler, and I am passing the URL. And now after the passing the URL, we will get all the QQ names which exist in our Redis. Okay, you can say our BullMQ, and all the queues which we have created for our BullMQ. Okay, so by the way, it's look like some kind of library which we used for connecting to, maybe like you can say the recent. Okay, because recent also has similar setup, and also Sentry also has same kind of setup. So it looks like that na? Because this is possible due to the class. Okay, we are using the class and we can pass the state in the class, and we can just use that state from the class. It's awesome thing. Okay, now let's see what the configurations on BullMQ packages. So now let's come on the packages side. Okay, so there is a packages and there is a BullMQ. Now let's see, first see the index. Oh, there is something. Okay, it's a configuration file, something here. Let's see what inside this. And yeah, if you come here, so you can see there is a class. By the way, I think this is called ops. I haven't too much knowledge of ops, because in JavaScript there is no ops concept. So you can just totally ignore that in JavaScript. So I also ignored that. But in JavaScript there is a class. So I have multiple thing. I think it's class concept is comes under the oops. But okay, who cares? Here the Redis, IO Redis. Why I'm using IO Redis? So IO Redis is just for a library, a third-party library to connecting, or you can say the managing the Redis connections and Redis operations. And also there is a QQ option. It's a type coming from the BullMQ. Okay, and it's a QQ name. It's something. Let's see what inside this QQ names. Now let's see what's this. So here you can say all the constant, because It's a name. These are the names for our queues, because in the BullMQ depends on Redis, and Redis is like key value pair thing. So you can say these queue names are used as a key for your Redis, and in the key they will store list thing, or I don't know how they are handling this thing internally, but they are using the uh, just they are using Redis. I did no. And there is a queues. Okay, so now let's see what's inside the queue. So in the BullMQ, you first need to create a queue. If you create the queue, then you will able to add a jobs into queue, maybe your messages, yeah, anything. So we have already seen how we will add jobs into the queue. Just take your queue and add and pass name and pass your job. And now here, let's see how we will create a queue. There is a something BullMQ option. Okay, we already see this in our handler thing. So here we are just creating our option with 3 retries. Okay, and now here we are just creating our a queue. Okay, in the BullMQ, you need to create a queue. For to create a queue, you just have to define, I mean, queue is a class. You just have to create an instance of that class that will create a queue. And if you pass your first argument here, it's a January, then it will your job type. Okay, if you add any job here, so that will take that type. If you try to a different type, so TypeScript will throw error. Hey, क्या कर रहे हो बे? सही करो इसको. And here, no, it's a queue name. We have to pass the queue name, and there is a BullMQ options. We need to pass the option which kind of settings we want for our queue. And was by the way, you can also set these settings on job level when you will add job. Multiple things to do. And now here, it's a Redis URL which we will taking from our where we will use when where from where we will create an instance for this. So here I am just creating a Redis instance, which is the IO Redis instance. Yeah, you can say coming from the IO Redis, and just a max retry root thing. These are just a Redis thing. Okay, I am just when we will get the URL. By the way, this sequence matters here, because first we need to take URL. Okay, for Redis, where to which Redis server we wanna connect. If you put this first, so if you put this first and this after that, so at this time you have URL undefined, so you will that this will by the way, so this will throw error, connection failed. Okay, so the sequence matters here. First you have to take the URL and set the URL in your prototype, and then create a Redis instance. Okay, and set also that instance in the prototype. And after that, there are some listener, because now our Redis client is set, so now you are able to listen all the events from the Redis IO client. And after that, this BullMQ option is depend on the Redis IO instance. So this is after that. By the way, dependency and sequence matters here. And here the connection, it's a connection thing, prefix, and the job attempts and back off and thing how you wanna do. These are just settings you can read on the website. So here just you can say the QQ names. Okay, so we are importing everything. You can say we are importing everything as a QQ name from our constants. And here you can see in here get QQs, we are just running our function. It's a QQ and this is function, and in the function we are passing our options, and which is taken here. You can say, yeah, here, and we are using that to create our 3 retry thing, and just creating this. Okay, so it's done. Okay, so we have done here. It is pretty much enough in our BullMQ BullMQ packages, and there is not more than that. By the way, if you want to see our package JSON, so there are some import to define to where what you want to export, and from where you want to export. And you can say there is a dev script. By the way, this dev script .watch also available here. This will just do, if you run this, by the way, if you run the dev script from the root, so that will also start dev server of packages. But if you change anything that will reflect instantly. Okay, that will build instantly. You don't have to build manually, so it's like automatic thing. So now let me just show a overview. So you can say there is an index.ts file, and there is the build. Okay, let me close others, and there is an index.js. Okay, so this is a non-build version. Maybe it's you can say it's a TS version, and this is the build of this file. Okay, if I add our dev server is started. Okay, you can say we run the dev server in root, so that is start everything. Okay, so if you try to add any console here, let's suppose sole console dot log and just any empty. Okay, so you can say this is started and this is trying to build. And if you come here now, you can say you have you you already have that thing in build. Okay, you do not need to run manually. It's believe me, it's important. If you have too much big project, then it's also important, and it's to automatically do some things. And but if you have a system that have limited resources, so it's also the problem. My system has limited resources, so that's why I never run multiple servers at once, because we also need to use Kafka, local Kafka and Docker container, Redis on Docker container, Postgres on Docker container. I need to use multiple things. That's why I always like to off my server when I need, then I start it, and then I will start any server. By the way, your server is too good. If your system is too good, maybe you have back, maybe you have ultra processor of Intel's, so you can use. Okay, so now I think we have done with our mediator server. So it's done with mediator server and web with mediator server. Now here you can see we have mail server. So by the way, if you come in the index of this mail server, so there is no, because we do not need to expose anything. You can say we do not need to create any endpoint, because we do not need to connect directly with any HTTPS request to this server. That's why I haven't used any uh, that web. I don't know what to say, Hono, but no, I haven't used the Hono because I do not need to create a server. Okay, that will available locally with a HTTP on HTTPS, so port number I think 80. uh, so now here it's just a .env file, because this required env configs and also workers, because you need to start workers. Why I added here, I will explain everything, just wait. Okay, so if you come here, there is also a BullMQ folder. In the BullMQ folder you have config, so you will also feel the same config. Here we are just passing our Redis URL. Okay, we are using the same setup. We are using same setup in mediator, and also we are using same setup here. So it's really a great thing to create a package. Okay, so I think it's done. So if you come here, you can see here worker. This worker has all the workers. Okay, all the workers here. If you want, you can also create a function, and you can import that function here and run that function here. You have multiple things to do, but I always like to avoid the functions and method and classes as much as possible. But it's also not possible, because if you want to create any reusable things, then you need to use. Okay, so now let's see the high priority thing, what we are doing here. By the way, now it's time to see how we are managing the priority with queues. Okay, so you can say there is a worker. Okay, it's also in the boolean. If you want to define the queue, you need to use the class queue, and you need to create a instance of that queue class with new keyword. And also for the worker, you just have to use the worker class with new keyword to create an instant of that worker class, and you have to just set these to get a state for that worker. So it's a worker, and the first argument of that worker is the which kind of job, which type of job you want to receive. So if you add this as a first argument of this generic, so after that our job type is defined. You can say we are getting the defined type. If you remove this, so this type becomes any. So it's must to do thing at the top type here. And the second argument of this generic is to return type. If you want to return anything here, so that will not automatically gonna infer, so you just have to define your type, which kind of thing you want to return. So I am not returning anything here, so it's a void. Okay, it's a void. By the way, I also created a return example, so worry not, I will show you. So here you can say the queue key. To create a worker, you need to pass the name of the queue, not the queue. You just have to pass the name of the queue, from which name you have created the queue. So just pass the queue name. Okay, so the first argument is to queue name of this worker, and second argument is the callback function. And the callback function, you will get a job. This job have multiple things. This job retries name. You can use and create atomic city. Atomic city, I think it's called atomic code. I'm not sure about the atomic code if in future, but if I will makes you run something on atomic. So I will also share you. I think that called FSM model. I think FSM model is outbox model. Oh, I totally forget it. Just ignore. I here it's a queue. Here also I am using the queue. You can see it's our master queue, which I have already explained in my diagram. So it's a master queue, and just send me a name. And here the and third argument is our connection, our configuration for the worker. A worker also want a configuration, and there is a connection, and in the connection you have to pass the client, Redis client. Always make sure pass same Redis client, okay, which you use for your uh, queues, and also pass that into here. Or how you will do that? Because we have the separate wrapper, there's a separate package. So you can say I am just instantiating the client from our uh, handler, because I made that handler public, so that is accessible anywhere. Okay, so that's why I am able to do. And you can see the concurrency 20. I think in diagram I already explained the concurrency. So this have multiple workers to work on the job, so that's why it's high priority, and we will down the priority to decreasing the priority. Okay, I mean say we will down the concurrency to decrease the priority. So there is a concurrency, and there is a limiter if you want to limit your jobs per second, per 5 second, per any second, so you can limit. And yeah, make sure prefix, I am using the prefix is mail queue. Okay, if you use any different queue prefix, then always make sure you use same prefix and also in a queue and also in worker. Okay, don't avoid this. If you're not using the prefix, then it's okay, but if you are using the prefix, always make sure pass same same prefix as your queues. And okay, I think it's, oh yeah, you can see maybe somewhere not there. I think it's on config. Yeah, you can see also for queues I use the same prefix. Always make sure you use this. Please don't ignore this, because it's if you ignore this, this will throw error and you will not able to detect, because it's already happened with me when I used first time the BullMQ. Then I also oh okay, no, come here. And it's a high priority thing we have already talked. And you can say there is a some listener, if fails to do something, you can create a queue for storing the DLQ, or just send that log into the entry. You can create logs in your database. Multiple things to do, you can do. Okay, and now here you can see we have low priority thing. So it's the same thing here, and just the difference is the concurrency is low, and also with medium, and just concurrency is change, and everything is same. And there is our master queue, and the master queue I created a 3 files. I will explain, worry not. You can see here it's a static thing. By the way, here you can say okay, I think I opened the handler. Okay, so now you can see here what we are doing here. We are just creating a worker with first type argument, and there is a second thing, which kind of thing we will return. So it's our return type. Okay, so you can see we are just returning await handler and handler mail as send. Okay, and it's pretty much enough. And the concurrency of this is high, and also I have set the limits here. I don't know the limit of the resend, but I have just set 300 messages per second. But it's depend on system. Okay, if you have different system, that will limit will be different. Okay, so don't rely on the number. Just test these bit the okay, running the things. Okay, because it's also depend on system. Maybe you have maybe you have your VPS have too much resources, so maybe this will spike the 300 messages. Okay, so it's already happened with me. And there is also prefix. Okay, so and there is a complete, on complete do something, and on failed do something. So now you can see these are the handled by a handler. So now let's see the handler. So you can see there is a handler, and the handler is create. Okay, so you can not create, just send static class send, and the job type, and also the promise, and just doing I am just doing the something to send the mail, because these are the recent thing. So it's a recent setup to send the mail. I think I do not need to show anything here. If error, throw error. If not error, return. So data return type is, you can say, the same which we already seen. And on complete, You can see here the on complete, and in the on complete, if you want to do anything you can do, or you can just ignore if you want to ignore. And all failed there as on failed. If you are thinking why I created the separate logic here and why I haven't created the separate, because in the here the code is totally predictable now. Okay, but maybe I don't know about the future, but now it's totally predictable. But maybe here the code is not predictable, maybe it's have some bug and you don't know. So it's always to have create some kind of utils like this, and you have to run the test on that code to make sure everything is predictable and everything go as your wish. Okay. The test, because this kind of code, this kind of small codes help us to write unit test. Okay, so that's why I added here. I because I wanna show the test case. By the way, one thing I wanna tell you, I am not too much involved in test, so I haven't too much knowledge of test cases. But I added to just show you. I am using the VTest as a test runner, so if you want you can use Jest. There is multiple library, and that's pretty much enough. So let me show you that it's a recent configuration. So it's a recent configuration, just a simple configuration. As we have already seen, we have created our own library. So, and you can see this has also env.example, so you just have to put. And now I think it's enough, and now it's pretty much all. So now let's buy.